So let me ask you a question. How many computers did you use today? You're probably thinking, well, my phone, my laptop, maybe two or three. But what if I told you it was probably dozens, maybe even hundreds? We are literally surrounded by hidden computers. They're in our cars, our kitchens, even in life-saving medical devices. They are the invisible engines running our world.
All right, so to kind of pull back the curtain on this secret world of technology, we're going to start with a little puzzle.
I'm about to show you four things you see all the time. As they pop up on screen, just think, what's the one secret connection they all share? You ready?
Okay, first up, your car's cruise control. You know, that amazing system that just automatically holds your speed steady on the highway so you can relax your foot a bit.
Next, think about a simple digital watch. I mean, it does way more than just tick, right? It keeps track of seconds, minutes, hours, the date, all with perfect digital precision.
How about a vending machine? You put your money in, you hit a few buttons, and somehow this big box knows exactly which snack you want, grabs it, and drops it for you.
And finally, the humble microwave oven. It cooks your food for a super precise amount of time at a specific power level, all just from you pushing a button.
So, did you figure it out? The secret, the common thread, is that every single one of these things has a tiny, dedicated computer inside of it with one single job. And in the tech world, that's what we call an embedded system. Okay, so that's the name. But let's really dive in and get a crystal clear idea of what an embedded system actually is.
Just think about your laptop for a second. It's a total jack of all trades, isn't it? You can browse the web, play music, do your taxes, whatever. An embedded system is the complete opposite of that. It's not a generalist, it's a specialist. It's totally laser-focused on one single dedicated mission.
You know, here's a really great way to think about it. Your PC, it's like a Swiss Army knife. It's super versatile and can do a whole bunch of different things. But an embedded system? That's more like a chef's paring knife. It is perfectly designed for one very specific, very crucial task. So, how do these little specialists actually pull it off? How do they get their jobs done? Let's take a quick peek under the hood. At their very core, they're basically just tiny, low-cost, low-power computers that are tucked away inside of some larger machine. They're not meant to be seen. They're designed to just work flawlessly in the background.
And the way they operate is this simple, really elegant loop. They sense something, they think about it, and then they act on it. So let's go back to that cruise control example. A sensor is constantly monitoring your car's speed. The processor inside sees that you're starting to slow down on a hill. The software then decides, hey, we need more gas, and an actuator physically opens the throttle. It's just this constant cycle of sense, think, act, over and over again.
Now, once you understand that basic process, you start to see how it can be applied to a huge variety of jobs that these hidden workers perform all around us. I mean, their functions are just incredibly diverse. They monitor things like an ECG machine that's tracking a patient's heartbeat. They control things like your car's anti-lock braking system, making sure your wheels don't lock up. They collect and communicate data, like a digital camera or your Wi-Fi router. They even process signals, like a digital hearing aid that's filtering out annoying background noise so you can hear clearly. And they do all this with a huge range of interactivity. Some of these systems work completely invisibly, with no user interface at all. Think about a sensor in your car's engine. You don't even know it's there. And then you have others, like the incredibly complex system in your smartphone, that are built entirely around this rich, graphical interface that we're interacting with all day long.
But, building these things isn't as simple as just shrinking down a desktop computer. They come with this really unique and demanding set of design challenges. For these devices to end up in billions of products, engineers have to perform this constant balancing act. They've got to be cheap enough to be mass-produced, small enough to fit basically anywhere, and incredibly power efficient. Sometimes they need to run for years and years on just a tiny battery. But maybe the most critical constraint of all for many of these systems is time. It's not enough for them to do their job correctly. They have to do it at exactly the right moment. And this leads to a really important distinction. For what we call soft real-time systems, like your TV remotes, a little delay is maybe annoying, but it's not a disaster. But for hard real-time systems, missing a processing deadline even by a tiny fraction of a second could be absolutely catastrophic.
This quote about a cardiac pacemaker just captures the stakes perfectly. A pacemaker has to deliver that electrical signal if the heart misses a beat. There is zero room for error. That is the life or death importance of a hard real-time system.
So it's clear these tiny, specialized computers have already reshaped our world from the inside out. But believe me, their story is far from over. Because now, they're starting to connect to the internet. Think about smart door locks you can control with your phone, or your Wi-Fi router being able to download and install its own security updates. These connected devices are the actual building blocks for what we call the Internet of Things.
And that really brings us to a final, pretty mind-blowing question. We already live surrounded by billions of these hidden computers, each one doing its own little job in silence. So what happens to our world when they all start talking to each other?